Okay, what we want to test today is to test the copy constructor, the equals operator. We also want to test the static attributes and also constant attributes. We talked about them 2 weeks ago, and also static and constant attributes. So we will do again another cover of those. And for that, it's obvious that we need a class which has at least one dynamic field. So let's take two. And I will introduce something new. Let's introduce an array, a dynamic array of strings. Okay, so let's also increase a little bit the complexity. So in the end, you will see that it's as any dynamic array, but it's is of strings. Okay, so because I will use the standard namespace a lot today, so I don't want to waste time by writing the standard prefix. Okay, so let's take, because it's, let's say, the season of deliveries, let's create a class for a delivery van. Okay, so you have a courier company and you want to define to manage their delivery vans, and let's say we want to track their location or to help them manage their journal, okay, their delivery journal, which means you need to go there, you need to deliver that amount of boxes. After that, you go there and there and there. So that will be our delivery van. Okay, so what describes the delivery van? So let's say we have a driver. Okay, so at this point, we know we have a designated driver for that delivery van. And now let's introduce the main content. So the scope here is to manage what the delivery van will actually do, what it will transport. So let's manage the locations. So this will be the journal. Track journal is like they need to go to Piazza Romana, and after that they need to go to Piazza Uniri, and after that maybe to Piazza Vittoria, whatever. So you see, we have different locations, and in the end we will want to store something like this, a collection of strings. So something like this, Piazza Romana, and after that maybe they will go to our faculty, which is Scala de Robanzi. Okay, and okay, and after that maybe to Piazza Uniti. Okay, so how do we define an array which is able to do this? Now we know that in order to manage a single array, so this will be a location, a single location, we can go for a dynamic array location, or we can go for a static one. Okay, location of let's say 50, if we believe that 50 characters here will be enough to cover anything we can reach in terms of locations. So this is for managing a single location, and we know that. Now, in order to manage multiple locations, we need an array of this stuff. So in order to define an array of stuff like this, we can say this is the locations array, and I want to go for, this will be like a static. So here we can manage at most 100 different locations. And now what's the type of each location? It's a dynamic array of characters. So in this way, you have, this is a static array of maximum 100 characters, okay? Sorry, strings. And each string here can have any size, okay? Now, if you want to define a static array of static chars, so how do we define an array of locations which have 50 characters at most? Then you say this, locations. So we want 100 locations, and we know that each location will have 50 characters. So this will be an array, a static array of 100 static arrays, each having 50 characters. So it's an array of this. And some of you will say, this is a matrix. Yeah, it's a matrix. But actually, what's a matrix? A matrix is an array of arrays, right? So yeah, this is a matrix, or it's an array of strings, of static strings, static arrays of chars, each having 50 characters. You see, one can say it's a matrix, but it's actually an array of arrays, because that's actually the definition of a matrix, okay? The table is only in our head. In memory, it's always an array of arrays. Okay, so this is if we choose to work with the classic C implementation of strings by either going for a static array or by going for a dynamic array. Okay, and here you have an array of dynamic arrays, and here we have an array of static arrays. And if you want to define a dynamic array of dynamic char arrays, so if you want that locations could be able to handle any number of locations, not just 100, maximum 100, then you say this will be a dynamic array of other dynamic arrays. So this will be your dynamic solution. So here you can have as many locations as you want, and each location can have as many characters as you want. You just need to allocate it. And again, some of you will say, hey, this is a matrix. Yeah, it's a matrix, but in the same time, it's an array. It's a dynamic array of dynamic arrays, because that's actually a matrix. Okay, so this is the C way, okay? Because in C you have char and you have pointers to char. Now, let's not dive into this and lose ourselves into pointers. Let's take it gradually. So I will use the string C++ object, because this will help me manage much more easy a single array. So for our solution, the locations will be a dynamic array of strings. So again, it's dynamic. I know it's a pointer to an array, so I'm not limited to a fixed number of strings. I can manage any number of strings. For that, the delivery van can cover any number of locations. Okay, so we will go for this one. Okay, and I will leave these comments here. So let's say here, this is a dynamic array of chars with any size. That's the power of pointers. This is a static array of chars with 50 characters chars, okay? Because that's the idea. Static arrays are fixed, okay? You can't exceed them. We talked about this many times, okay? And this is a static array of maximum 100 dynamic arrays of chars, okay? And this is a static array of 100 static arrays, each having 50 characters, okay? And this is a dynamic array of dynamic arrays. So dynamic array of dynamic arrays of chars. Okay, now we will use this one because this will be our dynamic array of strings. Now, in terms of which is the equivalent to this one here, which one do you believe? So here we will have the power to add as many locations as we want. And we know that string can allow us to store any number of characters. So based on the alternatives in C, which is the one which is equivalent to this one?
From location.
Which one? Which line?
10, I think.
So if it's 10, this is a dynamic array of chars with any size. So how many locations can we store here in this pointer? This is one. And here we want to store many locations, each having any number of characters. So it could not be this one because this is only for one location. Let's check chat. The last two are equivalent, 15 and 17. 15 and 17, exactly. This is it. Okay, so this is the equivalent. You have the dynamic array of strings. And remember, in a string, we can store anything. Okay, that's the power of strings. It's actually the equivalent of this one. And we don't need to allocate, we don't need to deallocate. That's the beauty of it. Okay, so this is actually the equivalent to this one. Okay, so I will comment all this stuff. And actually, I will move it here because it will prevent us see the class. Okay, so you will have this here. Okay.
Teacher, but
Yeah.
I don't understand because char double asterisk locations has 2 asterisks and string locations has only 1.
Why? Because what's the equivalent of string? So when you say string name equals test, okay, you see I can store any value here with any size. So this is the C++ string object. In C, how do you define the name? So you will be able to store any an array with any size. Name will be what? Can it be name of 50? Can it be name of 50? Like this? What do you think? Is the same? What's the issue with this one? What's the issue here?
It's char has only 1 character.
Yeah, but how many characters do we have here for name?
50.
50. So the issue with this one is that here you can use it to store a name which will not exceed 50 characters, more precisely 49, because you have the backslash 0. But in a string, can I do this?
Yeah.
Yeah. So can I'm limited here to only 50 characters, or I can write any number in a string?
Any number.
Any number. So is this equivalent to this one? No, it's not. No. Okay. So which then is, what about this? So this is a pointer to a char array. Do you have any limitation for that char array? In heap, for example, can you store there only 50 characters, or can you store any size? Obviously, before that, you need to ask for that space. So I'm here limited to only 50 characters. No.
No.
Because here I can say this, name equals new char of string length. I need to allocate, okay? And I can allocate this one, for example. I don't know what's the size, so +1. You see, I can allocate any size. So in terms of equivalency, this string object from C++ is actually allowing us to actually work with char arrays like we would do it in C with the char asterisk, okay? So string is actually an equivalent for the C char asterisk dynamic array, okay? So it's clear this?
Yeah. But we cannot write char name equals test, for example?
Here? Yeah, you can.
Without the asterisk.
Char name like this?
Yeah.
Yeah, but when you say char, this is a char variable. What's the size of a char variable?
It's 1 byte.
1 byte. So can you store this into a 1 byte?
No.
No.
Okay.
So char is just 1 byte. Char is like int VB, but instead of being int, which integer has 4 bytes, char is just 1 byte. Remember, it's a numeric type. We covered that because we store ASCII codes, right? We don't store letters. Okay, so char is just a char. What's an array of characters? What's a string? It's an array of characters, you see it? So obviously we need either something like this, or we need either something like this. A pointer to the first char in this array. Okay?
Yeah, so the size of string is very big, right?
Exactly. No, is actually the string object is smart enough to manage its own size. And that's why we don't care, we don't need to allocate. Okay? So just think at this as a smarter char asterisk. But you see, the char asterisk approach is quite dumb because we need to allocate it before we copy this value there. Remember, you need to say new string copy, blah, blah. But for a string, just think that they provided us a class which is able to do what we should do manually for a char asterisk. Okay?
Okay.
And this is from C++, this is from C. Okay. So you asked why here we don't have 2 asterisks. Because you see, 1 asterisk is actually hidden here in the string. You see it? If you make the correlance that string is actually char asterisk, so this is actually equivalent to this one, right? Because string is actually a dynamic array of arrays. And here we have a dynamic array of dynamic arrays of chars or of strings. So that's why they are equivalent. And that's why you don't need the two asterisks. You don't see the two asterisks. Okay, so we have the locations. And in this locations array, we can store this kind of stuff later. Okay, what else do we need here? Let's suppose we want to also know how many boxes or parcels they need to deliver at each location. So it's like they need to go to Piazza Romana and they need to deliver 2 boxes. They need to go to Cala de Robanți and they will deliver 1 box. So we need another dynamic array of number of boxes. Again, it's dynamic because you see this size, the array of this size depends on the size of locations, on the number of locations. So let's say number of boxes. Okay, so this is the other array, and we will keep them synchronized, which means if in this array we have 3 locations, then in this array we should have 3 values, and each value will contain the number of boxes that they should deliver here, here, and here. Okay, so we have 2 arrays which will have the same size always. If we mess them up, that will be a bug. Okay, to have more locations than number of boxes or vice versa. So we need to know how many elements are in these arrays. So let's define a variable, number of deliveries, because this is actually the number of deliveries.
And in order to have this like more like safer, could we assign like the location to number of boxes to be the location to number of deliveries, like in case somebody wants to change something?
Okay,
number of boxes.
Okay, so
the number of deliveries will have the old value, and this will be a problem because they have to have the same
number of elements.
Yeah.
So your use case is, if I understand correctly, what will happen if someone will add a location or remove a location? That was the question.
Yeah.
So because we say, hey, this number here will both represent the number of values here and here, it means that when someone will try to add a location or remove a location, then they will also add the number of boxes for the new location, and they will also remove the number of boxes for that location. Okay, and your question is, how do we do this in a safer way, right? I think that was the question. How can we do this in a safer way? Because in order to avoid removing a value or adding a value here or here, and forgetting to add or remove a value also in the second array, right? That was the question. How can we do this in a safer way, right?
Yeah.
Okay, so if you think that we will create 2 methods, one method will be called add location, and here we will get the location. And after that, we will have another function called add number of boxes, int number of boxes. Okay, then you are right. So yes, if we do this, if we have 2 methods and the developers, which could be us also, we are also developers, will have 2 methods to add a location and a different method to add the number of boxes, then there is a very high probability that they will call only add location or add number of boxes, and they will forget to call the other method, right? Do you agree with that? And that will be dangerous. But remember, we are in control. So how do we make the developers, if they want to change the location, to add a new location, in order to force them to add the location and the corresponding number of boxes? We do this. We say add delivery, and we ask for the location and the number of boxes. And here this is us, we are responsible, the others are not. Okay, we always believe this. We know what we need to do, our colleagues are a mess. Number of boxes. If I have this method instead of having these two methods, you see, what's the probability that now someone will try to add the location and to forget to add also the corresponding number of boxes? So if we don't provide this, but we provide this, what's the chance now? It's 0, right? Because they will be forced, if they want to add a new location, they will be forced to add the location and the corresponding number of boxes. So now it's more okay?
Yes.
Okay, you see, this is actually starting to design solutions. Okay, this is the moment when you realize, based on your colleague question, and if you start having these observations, if you start having these questions, you are not strange, you are on the right path. Okay, always question what others do or what you do, especially what you do, because most mistakes you will do it on your own. So always question that. And you see, when you start having this kind of questions, this is the way you will actually train your brain.
And now I think of another possibility, like
Okay,
assigning to the number of boxes the address of number of deliveries, and we can make both methods, like add delivery and add number of boxes, and every time we change one, the other one will also change.
yeah, but with what value? That's the question. When you add the location here, like Ploiești, what value you will add here if you don't receive it? What value do you add? 0?
1.
Why 1? Why not 5? You see? So if you let others do things in parts, you are responsible. You see, always we see the word as we will do it. So you will say, hey, I will add the location. By default, I will add 1. And after that, if I want to change it to 5, I will change it. And this is the way I will do it. But the others will not do this. They will forget. Maybe they don't understand that they need to do this in 2 steps. So in order to avoid all this misunderstanding, all this confusion, give them only one way, which will limit them to the right way. So ask for the location and the number of boxes for that location. So in this way, they can't miss that. If they call this add delivery with 0 here, is their problem. They call this function with 0. It's not your problem. You see it?
Yeah.
Okay. So yeah, this is actually programming. Okay, this is the level at which you will reach after this semester, after the second semester, after the other semester, and eventually in the last semester.
It also has to be more comprehensible for the person that for the customer, like the person who's inserting the.
Yeah, but that's not the customer, because the customer will not call add delivery. That will be another developer who maybe designs the UI. And if that developer will see that you ask when you add the delivery, the location and the number of boxes, maybe that colleague will design a UI in which it will ask for the 2 values, because you see, that person will know that in order to call add delivery, it needs the location and number of boxes. So again, you see, you actually, based on this decision, you have an influence on the UI, because you force them to give you these 2 values. So the UI guy will ask for the 2 values. Okay. So this is the control, and this is actually the power of object-oriented. Small decisions here can have a very important effect on how others will continue developing this software. Okay, so we have 2 dynamic arrays, and each array will have the same number of values, which is given by number of deliveries. Okay, so let's implement this method, and obviously we want to make it public, right? That's the idea, to make this method public, because others will want to add locations. So what do we need to do here? We need to add a new value. this value into this array of strings and to add this value into, yeah, let's choose here a different variable name. So let's say number of boxes for location. Okay, so I want to remove any confusion because this is just an integer here, and here it's an array of integers. So we just want to add this value here. Okay, so let's remove the confusion by adding, renaming the variable. Okay, so how do we add a value into a new array? Doesn't matter if it's an array of strings or whatever. We just create a new array with size +1. We add the new value as the last one, and we keep the new array. So let's do this for a number of boxes. Let's start with something, let's say you already know. So here I will define a new array. So new number of boxes equals new int of this number of deliveries +1. So this is my new array. Now we copy all the values from the previous one. We don't want to lose them. When you add a new location, you don't delete the previous locations, right? So I0, I less than this number of deliveries, I++, okay? And now I will say new number of boxes at index I equals with this number of boxes at index I. So we copied all the previous values, and now we need to add the new one at the last location. I didn't change the number of deliveries yet, it's not updated. So the last location is actually number of deliveries, because remember in C, the index starts from 0 to n-1. So this is n, which means the new value. So here I will say new number of boxes of this number of deliveries equals number of boxes for location. Okay, so right now we created a new array, we added the new value. So what will happen with the with the previous array? Remember, we don't want to keep that anymore in heap, and we don't want to create a memory leak. So I will say delete. So I'm deleting the previous array, number of boxes. And now my pointer will point to the new array. So here I will say this number of boxes equals new number of boxes. Okay, so now I have an array with a size +1, and I have a new value there as the last one, which is the one received here. Okay, how do we do this with the dynamic array of strings? Exactly in the same way. It's still a dynamic array. Yeah.
Why don't you write the 28th line before the delete?
This one here.
Yeah,
if I write it here, okay, this is a pointer, right? So let's draw the image of the memory. So you have this object, which is the delivery van, and inside of it you have the number of boxes pointer. Okay, this one here. So this is the pointer number of boxes. Now let's suppose initially here, before we called add delivery, let's suppose here we had this address A. Okay, so #A. So which means that this points to heap, where let's suppose we have an array with some values 1, 5, 8. Okay, so you have this image right before you call add delivery. So let's see here in the function, we do a new array. So we create a new array, and we'll have a second pointer, which this one is called new number of boxes. So this is the at new number of boxes. Okay, here we create in heap a new array with size +1. So yeah, let's create it here. Okay, and it will have 4 values, 1, 2, 3, 4. Okay, so that's the effect. And let's suppose we get this address B, because it's a new array. So this will point here. And now we copy the values from here. So the for loop will do this, copy 1, 5, 8 here, right? And now we add on the last location. Remember, number of deliveries is 3. So here is 0, 1, 2, 3. You see, it's the last one. So let's suppose here we add 10. Okay, so it's the last value. Okay, so what we want to do here is to delete the previous one and to make this pointer to keep the new one, the 158 with 10. So if you do the this number of boxes equals new number of boxes, what will be the effect? Let's see. So this is a pointer which takes the value of another pointer, which means this value from here will override. Yeah, so just think this as a variable. This is number of boxes, which is this one here, equals new number of boxes. So you take this value, pound B, and you write it here. So that will be the effect of this number of boxes equals that, which means now this pointer points here. And you may say, yeah, it's okay. This is what we wanted. Yeah, but what happened with this one here? What's this? How do we call this array, which is left in a heap and we have no way to reach it? This is what?
Mentor.
Okay, so when you write this number of boxes equals new number of boxes, you just created the memory leak and the story is not over. So this is a bad day for you, because what's the effect of delete this number of boxes? Which array do you delete now? When you say delete this number of boxes?
It's the last one that we assigned, isn't it?
Exactly, it's the one at address B, which is this one. So now you delete it. So yeah, it's worse than before. You have a memory leak, and now you have a dangling pointer, and the app will crash instantly when you will try to reach this, because there is nothing there. Okay, you see, by just reverting two instructions, we go from, hey, it's a happy day, to it's a bad day. Okay, so it's clear?
Yeah, for me, it seemed weird just because we first delete this number of boxes and then we assign to it the new number of boxes. Basically, what we are going to delete with our delete instruction, the 158 array?
Yeah. So is the array at address A. This is what the one that I want to delete, and I want to keep the one at address B. You don't want to keep this anymore in memory because you have a new one with the previous values and the new one, right? We don't need this one anymore.
Yes, but how can we attribute to this number of boxes something after we've deleted it?
Delete does not destroy the variable. Delete destroys the memory allocated in heap. So when you say delete this number of boxes, the variable is still here. You just go into heap at this address and you delete that space, but you don't delete the variable. This number of boxes, it's a variable. It's a pointer, right?
Yeah.
So when you say delete pointer, you don't delete the pointer. The pointer is still there, but you actually release the memory from heap at the address given by the pointer. So delete is not destroying the variable itself. It's not destroying this variable here, this box. It's destroying the space in heap at that address. So after delete, you still have this box. And after delete, you need to write here a valid address, because after delete at address A, there is nothing in heap. So that's why after delete, we say, hey, let's put in the pointer, in the red box, the address of the new array. So delete is not destroying the variable. It's releasing the space.
Okay, yeah, that makes
okay?
sense. Yeah,
so delete is not destroying variables. It's just releasing the space. The pointer is still there, and you need to place into the pointer another address. So if you ask me, hey, after we do a delete and we are not in the destructor, should we place another address in that pointer? The answer is yes. And if you don't have an address, what's the best value you should place in number of boxes until you get a new address? What's the value that will tell you, hey, this pointer is pointing to nothing? After you do a delete on that pointer, what value should you place here when you don't have an address?
Null pointer.
Exactly. So every time you delete the address given by a pointer and you don't have a solution for a new address to that pointer, always set null. Because that's at this moment in time, here, after this instruction, this is a dangling pointer. The value here in the pointer is still A, but do you have any space here at address A in memory after delete? No, this is a dangling pointer, right? It's a pointer which gives you an address at which you don't have space anymore because you cleaned that up earlier. So for a fraction of a second between this instruction and this instruction or this one, you have a dangling pointer. But fortunately, the next instruction is saying, okay, wait a minute, I will give you another address. So here we place B. And we take this address from the new array, from the pointer which is managing the new array. Okay? So it's much more clear now.
Yes, much better.
Okay. Okay, always draw. Do this game. Take a piece of paper, draw the memory, especially with pointers. It will actually help you visualize the addresses. Just take some, I don't know, imaginary addresses, but start drawing, because that will really help you manage the memory. Yeah.
What happens if just, I mean, I don't know, maybe stupid. What happens if we don't delete the location and we delete the whole pointer? Like,
you can't delete the pointer. Why you can't delete the pointer? Where is this number of boxes variable? Is
it's in the class delivery van, yeah.
No,
And
it's in the object. It's in the object.
Yeah.
Along the name and the other pointers. So can you go to an object and say, hey, I don't want this field anymore. I don't want this attribute. You can't. It's there. It's always there. Why? Because this is the way you define the class. You see it? So you can't delete the attribute. You can change the value of the attribute. We know we can that. We can change values for variables. And if this attribute is a pointer, and here you have an address which is pointing to heap, yeah, you can delete the heap space to which this pointer points, but you can't delete the pointer itself. Okay, so we can't. Okay, so if you have questions, feel free to ask. This is the way we learn. Okay, so that's why here I'm avoiding the memory leak. So this is that's why, because we can go without this delete. Okay, maybe no one will notice it, but we know that in time those memory leaks can pile up, and in the end will happen what I showed you at the course. You run out of memory and the process will be terminated. So that's why memory leaks are dangerous, because generally they will terminate your process later. Okay, you don't see that immediately. Okay, the app will not crash then, but later it might. Okay, and here we take the new address. Okay, so this is the add delivery. Okay, so now we can add a number of boxes. Now let's handle how do we add the new location to here, to the locations array. Remember, it's still a dynamic array. So you take through the same procedure. You create a new array with size +1. You copy the values. You add the last one. So it's the same process. The only difference is that instead of having a dynamic array of integers, now you have a dynamic array of strings. But we know that we can use strings as an integer, so you can assimilate them. So this is the new locations array. Okay, equals new string of, again, this number of deliveries. I don't know why the IntelliSense is not helping me with this one, and I need to write the variable name. But yeah, sometimes it's happening. Again, here I can do a for. And you see, you asked me earlier, what's the perfect solution? I think you can now see, some of you, that we can actually combine the two fors. Okay, you can actually combine this with this one, and you copy both arrays in the same time. And again, that's okay, but this also will work. So it doesn't matter how you write it, as long as it works. Okay. So
and at strings we also have to add the /0 thing.
No, that's another advantage of using strings. The string object is managing its own by its own the /0. You don't need to add it.
Then why did you add one? Just because you that number of deliveries +1.
Yeah, this
Yes.
is not for the backslash 0. This is to add a new element in this array.
Ah, okay, okay, okay.
So
Yeah,
so +1, it's because I want
yeah,
to add into this array another string.
yeah. You forgot
Mhm.
that what was
Mhm.
containing that variable.
Okay, you see how dangerous is to actually try to find patterns or to memorize them, because the +1, as you said, the first impression was, hey, it's adding a backslash 0. It's no, here +1 means, that's why you need to understand everything we do. So don't take anything as granted. If we said the +1 yesterday, today this +1, it has a different meaning. So yeah, always go to for what's the meaning of that. Okay, great. So what we want to do is to copy the values. So new locations at index I equals with this locations at index I. Again, for strings, I don't need to use string copy, equals works, which is great. Okay, now let's add the new location. So new locations at index this number of deliveries equals with number of yeah, it's the new location. Sorry, it's location. I add this value from here. Okay, and now again we need to avoid the memory leak, so we delete the old array of strings locations, and we keep the new one. So we change the address from our pointer to the new address, new locations. Okay, and now we added this value to the new to the array of locations, and we added this value to the array of number of boxes. So the only thing that we need to do in order to finish this method is to update the number of deliveries, because now we have a new element in each of those two arrays, and we said both arrays will always have the same number of elements, and we try to keep them synchronized. Okay, so now we know how to add a new box and a new location and the number of boxes for that location. So you see, by having only one method, we covered 3 of the attributes. Why? Because that's the thing that we need to do. That's the story. Locations and number of boxes are related with number of deliveries. So again, no one says that you need to provide a get method for each attribute. Sometimes you can handle multiple attributes in the same time. Okay. We have the public interface, which will allow us to add a delivery. Now, let's try to validate here the number of boxes. So for that, just to use a constant and a static variable. So here, let's suppose we have this minimum number of boxes. So here, or maximum number of boxes. So here I will say const static int max number of boxes. Let's suppose that if you want more than 5 boxes, then you need a special transport. Okay. And here, let's define the minimum mean number of boxes. So you see, in this way, I can have these static attributes, which means they are not part of the object itself. They are related with the delivery van. Okay. And because they are constant, we don't need to provide the get to a public get method to them, because no one can change them. So in this way, I will make these const static attributes, I will make them public. Anyone can read them. Okay. And remember, others will use these values to validate. How do you initialize them? Again, you need to go here. This is the only way for statics. And it doesn't matter if they are constant or not. So here I will have const int delivery van. And this will be the maximum number of boxes. Let's say it's 5. And here I will have const int delivery van mean number of boxes 1, right? So you can't add a location and you have 0 boxes. Why do you add that location? Okay, don't deliver
We did
anything.
this because we wanted to globally assign this, or
Yeah, because actually in C++, static variables, the compiler is actually managing the static variables as global variables. So that's why this looks as we assign them globally, because actually they are using global variables. Okay, that was the way to handle statics in C++. And that's why it's asking us to redefine them and initialize them globally. You see?
But we couldn't do it like up there in where we define them.
No. Now, for constant variables, that's allowed.
No, we wanted to use them. And if we do them public, we can change their values.
Yeah, but they are constant. You can't.
Okay. I got it. I got it right.
Okay.
Yeah.
So remember, for statics, if you try to do this, even if in my mind this should work, but yeah, this is the language, it's not perfect. So here, if you say, let's say number of what else, let's count the delivery vans, number of delivery vans. You see, if I try to initialize it here with 0, I can't. You can't, actually you can't. So that's why you need to initialize it globally. Okay, now this number of delivery vans, here we want to count how many delivery vans objects we create. So this has a different purpose, and you see it's not constant. So because anyone can change it, let's protect it. Okay, so generally constant static attributes, you can make them public because no one can change them. So they can only read them. But for anything else, you need to decide. Okay, so let's choose for number of delivery vans. Let's go for a private approach. And you see, I can't initialize it here. So again, the only way to initialize this with 0 is again to go here, int delivery van.
And it doesn't matter if we define these globals above or under.
We can have an issue because the C++ compiler, it's a top-down compiler. It's like it's going only one time from top to bottom. So maybe it will not see it. We can try this. I think we will have an issue because it will not see these variables because they are defined later. So let's initialize this one, and let's try to, let's define main.
Teacher, one question first. Yeah. But when we write the static and we don't declare it here globally, the error says a member with an in-class initializer must be const. Why doesn't it say you need to initialize it globally or something like that?
I don't know. We need to find the compiler creators and ask them.
Okay.
So you see, when you create a compiler, you'll have the power to show any error message. But sometimes, yeah. So I don't know. I don't have the answer to that question because this is the way they choose to implement it. So yeah, the error message it's quite misleading, which is not nice. And that's why at the exam, sometimes the entire experience will be a failure because of a static, because some people will forget to go through statics. They get the static requirement and they stop in the first 5 minutes and they look at that error as you just said, and they don't remember that the message is not clear, and they should remember that they need to initialize it here. And yeah, the exam stops then because that's easy stuff. So yeah, I agree with you. The error is misleading. It's not clear. Okay, let's try to check what your colleague said. Yeah, it's working. Okay, so if I do a build rebuild, no, it's not working. As I said, because you see when you use delivery van here, the class is not yet defined. So here at this moment, the compiler has no clue what's delivery van. Okay, so yeah, that's the issue with the C++ compilers. They check the source code in only one run from top to bottom. It's not like they need to know all the stuff when they reach it. So they will not look further. Okay, so in this way, we remember how to initialize constant statics and just statics, okay? Now, let's also add a constant here. So you have the driver, we have the number of location, number of boxes, number of deliveries. Let's define the volume of the delivery van, okay? So it's the volume of the van, okay? So depending on that, we can also determine how many boxes we can fit there. So let's say volume, and let's make, because this is based on the fact on the chassis of the vehicle, you can't change the volume, that's it. So it's constant, right? Const. Okay, so now we also have a const attribute for the delivery van, which is the volume of the van. Okay, so let's test at delivery. And in order to test this, we need to be able to create a delivery van, right? So always remember, every time you define the attributes, you see I'm forgetting this, but try to be better than me. That's the idea. So always set your defaults here. Okay. Make this to be a habit. Okay. Every time you define the attribute, don't forget to initialize it. Okay. 0. And for the constant, don't add a value, because if you add a value for the constant here, that's it. The attribute will have that value forever. You can't change it. So don't do it for constants, because we know that for constants, we need to use a different approach. So let's define the constructor here. Let's, yeah, we are on the public space. So I will not go for the default constructor, and I will go for the constructor, which, let's say, makes sense. So when we define a delivery van, when you just create the delivery van, it's a new van. What do you need to provide to that delivery van? What do you think should be mandatory? Do we need to provide locations and number of boxes and number of deliveries? I don't think so. No. It's a new van, right? That will be added later. So I think the driver and the volume. Okay. So let's define this constructor. So delivery van, string driver. Let's see. It's let's call this one driver name, and here I will say float van volume. Okay, you see, when you write the first constructor, you'll have the classic compiler error. It's saying this constructor does not provide initialization for the const member volume. You see it here. So in this case, the error is pretty clear. It's quite clear. It's just pointing to the error. Okay, and here we should remember that constants in C++ are initialized using the constructor initialization list, which looks like this. And now you say volume, the name of the attribute. And there, I know this looks strange. It's like this is a function, but it's not a function. And here you pass the value. So remember, we talked this at the course. Here you can pass a value, 0. But why would you do that? Because then all your vans will have the 0 volume. Here you can use this variable from here. Here you can use a static. Okay, so we have seen multiple possibilities. Now, which one do you choose? The one which is close to reality. So if you ask for the value, use the value, right? And remember that the initialization list can also be used for the other attributes, okay? Because this is actually equivalent with equals. So let's use it also for the driver name. So driver.
When we are going to make a delivery van, all of the following vans that we will make will have this van volume, right?
Yeah, but when we will create a delivery van like here, you need to give me that value. So you will have the chance to use different values for the volume. So for example, this will be van 1, which will be managed by John. And the van volume, let's say it's 300, I don't know, liters or whatever. Okay. And when you define a second delivery van, which will be driven by Bob, then you can choose, maybe this is a bigger van, so it has 500 liters as a volume and so on.
So even though it's constant, we can change it when making delivery vans.
Yeah, you see, we don't change it. We can initialize it when we create a van, and that's it. You can't change it otherwise because it's
Okay.
constant.
Okay.
So for constants, you can set their value only here by these constructors. And after that, they are written in stone. You can't change the van volume because it's constant. If you try, you'll get the compiler error saying it's not a modifiable left value. We have seen that. And that's why we ask for this value here. So now van 1 will have forever 300 liters. Van 2 will have 500 liters. Now the name, we can change the name. For example, here we can say void change driver. Okay, so string new driver. And here we can change the name because this is not constant. Okay, so here I can say this driver equals new driver. So we can change the driver's name, but we can't change the volume. And why we do this? Because this is reality. Okay, you can't change the volume of a vehicle. Okay, I don't know, you need to buy another one. Okay, so we have the constructor. Remember here, this is optional. And if you don't like this approach, for constants, this is mandatory. You can't otherwise. So if you don't like this approach, this is the equivalent of writing the classic, this driver equals driver name. Okay, so the other attributes can be managed like this, or if you start liking this approach, you can use it for other. Don't use this for pointers. Don't do shallow copy. Remember, don't use equals. Create a new array, so you need to write code here. Okay, don't use this approach for pointers because it will do shallow copy. Okay, now we have an attribute, we have a static attribute, which we said, hey, I want to know how many delivery vans we have in our solution. So if you have a variable, a static variable, which should change at different events, like creating a delivery van, because now we have a new delivery van, don't forget about it. Okay, so delivery van, number of delivery vans, plus equals 1. Okay, so every time we will call the constructor, it means we have a van created, so this static will increment. So after calling twice the constructor, this value will have the value 2. Okay, so it will be 2. Okay, now what do we remember? We remember that if we have a dynamic field in our class, we should watch out for memory leaks when the objects are destroyed. So we know that it's again our responsibility to clean up after our objects are destroyed. So for that, we need to provide the destructor, the class destructor. Okay, so every time you have at least one dynamic field, the destructor should be mandatory. Okay, so it looks like the default constructor, but with this sign here. And here we will just delete the space in heap because now the object is going to be destroyed. So we don't want to leave those arrays in heap. So I will delete the boxes array, and I also delete the locations array. Okay, so with this, we covered the destructor. And if you really want to see it, to see that this is actually called, play this game. Okay, so when you test stuff, all play print messages. You see here, I will say calling destructor. Okay, so if I will run this program, build, rebuild, okay, then I should see and play this guessing game. It's not a guessing game. You should estimate. So how many objects we have in our program? We have 2. So when the main function terminates, the main stack is destroyed. So implicitly, the objects here are going to be destroyed like this 2. So I will see this message 2 times. So let's see if my estimation is correct. So start without debugging, and we should see this. Okay, calling destructor. And see, I didn't did anything special in main. Okay, I just implemented the destructor, and now I see the messages, which means the destructor has been executed, and we are cleaning up that space. And
but don't we have to like call the destructor in main?
No, because what's happening with the function stack when the function terminates? Is destroyed, right? We know this. And what do we have on the main function stack? We have two objects. So when the function stack is destroyed, everything on that stack is destroyed, which means our two objects. And now the system automatically, the compiler, it's calling the destructor for those two objects.
Oh, I remember that in my assignment, I called it like in the main.
Okay, and please tell me how you did that. Let's.
Oh, let me take a look.
Okay, so this is that's why I like all this discussion during the seminar and the courses, because here we are allowed to say anything. It will not have any effects. We learn from that. But this is the moment which we can discuss it here. But at the exam, please, pretty please don't do this again. So let's see. How did you call it?
I said the object name dot what? Not that. Yeah, that. And the destructor name, like with the sign. Yeah, like that.
Like this, okay, and it worked.
Yeah, I think that. I mean, I don't know. I had an error, so.
Okay, so you see here you have 3 times. You call 3 times the destructor, right?
Yeah.
But this doesn't make any sense because we have only 2 objects. So right. So what's our luck or bad luck is that here somehow the compiler is not deleting these addresses twice. Maybe if you run this example on a Linux or on a different compiler, it will crash instantly. Let's think for a moment. So when you call van1 the destructor, we delete these spaces from heap, right? But the pointers will still have A and B, the addresses, because no one is changing them. Delete is not changing the pointer value to something else. It's just releasing the space. And after that, van1 is again destroyed because it's on the function stack. So when you try to delete the same address twice, the program generally crashes. Now, for some reason here, it didn't happen, but I will not bet that this will always work. So let's take this as a rule. Never call the destructor, okay? Don't do this again. Please don't do it. And this is one argument, because the object will also be destroyed again. And if you do here something like, let me give you an example. So we have this number of delivery vans, right? So here we count how many objects we have created. But again, when you destroy a van, we should also decrement it, right? We need to keep it synchronized with the reality. So here I will say number of delivery vans minus equals 1. So if you call this van1, van2 destructor explicitly here, this will be decremented. But again, when the function terminates, you have seen it's calling again the destructor, because we have seen 3 messages, not just 2. This will be decremented again. So here you will have a minus, you will have a negative value. You see, here you have a logic problem because you called the destructor. So let's take this as a rule. We don't call the destructor. Now, we can actually destroy objects, but don't do this with stack objects, okay? Don't do this with objects which are on a function stack. When it's safe to actually destroy an object, when it's our responsibility to do it. So if you have objects in heap, pointer to van, that's a different story. So here, in order to create this delivery van in heap, here, let's say this is Vader, and this is the volume of the van. Okay, now this is an object in heap. And remember, everything we create in heap, it's our responsibility to remove it. So the closest thing to calling a destructor is this example, when here you can later delete the object from heap. And now we are actually forcing the system to call the destructor. Because when you delete that object from this address, we are actually saying indirectly, use the destructor to clean up this van from heap. So this is actually the closest thing to actually calling the destructor, because otherwise we need to wait for this function to terminate in order to see those destructors. So right now, if I build rebuild and do a debug start without debugging, okay, you should see 3 times the destructor. So 2 destructors are for the van 1, van 2, and the third one is for that object in heap, which we explicitly create here. And it's our job, because if you don't do this delete, this is your memory leak. Build, rebuild, you will see only 3 destructors, but you will see, sorry, only 2 destructors, but we know we have 3 vans, 2 on the main stack and 1 in heap. And you see, just 1 second, you see only 2 destructors. So now we have a memory leak, because the Vader's van, it's still in heap. So that's why everything you create in heap, it's your job to remove it. So don't call the destructor, okay? If you want to test the destructor, test it like this. Create something in heap, delete that, and the destructor will be called for you, okay? So thank you again for that observation, because I think many others were thinking to test the destructor in the same way. So let's not do that. What else do we need to define here? So let's define the copy constructor. And remember, the copy constructor, it's explicitly called when we have this. And again, it's implicitly, and this is the dangerous part about the copy constructors, that every time you have a method print van which receives a delivery van by value, so if you call this method, again, we need a copy constructor to create a copy for this object that this method waits. For example, if I call print van and pass van1, the copy constructor will be implicitly called to create a copy of van1, which is called van here for print van. So again, here you have another copy constructor. And the third use case is when you have a function which returns by value an object, create van. So here I may say string name float volume, and here I will say delivery van temp of name and volume, and return it, return temp. So you see here again, if you just call this method, even if you don't take the value, create van of, for I don't know, Alice 600, okay, then again you have the copy constructor. So this is the explicit call to the copy constructor, okay, and these are implicit. But again, it's dangerous because we have a default copy constructor, and the default copy constructor, we talked about this during the course 2 weeks ago, will do a shallow copy. So you will have multiple vans sharing the same pointers, and the destructor will delete that, and we know what will happen. You get that win and TDLL error. Okay, so copy constructors should always be implemented in your classes, especially if you have a dynamic field. So, because now if I will run this program, it will crash. Okay, just let me show you. Debug start without debug. Okay, it's not crashing. It's not crashing because we don't have here any. And that's why it didn't crash when you call the destructor. Let me show you. Let's add some van1, add delivery. Let's say Piazza Romana. And I think now it will crash. Piazza Romana, and the number of boxes 2. Let's go to Calea Dorobanzi, 1517. This is the faculty address, 1 box. And now you see I have van1. Now it has an address. Let me test that. Let me see if it will crash.
Shouldn't it be van2 at delivery?
No, we just add them only to John. So John now has 2 locations to deliver. So Bob has nothing. Okay, so let me try this. Van 1, delivery van. Let's see. Build, rebuild. Let's see if I can now simulate the crash. Yeah, here it is. You see it? So it crashed. Why? Because we called the destructor twice, and when you try to delete the same address twice, it's crashing. So that's why please don't call the destructor explicitly, okay? So earlier we didn't got this error. Why? Because by default the pointers are null, and remember delete is also checking for null. So here it had nothing was happening, and that's why it didn't crash. But now we have those 2 pointers initialized, and when you call the destructor explicitly, you will delete those areas in heap. These 2 pointers will become dangling pointers. They will still have the addresses, but is nothing there for you anymore. And when the program normally terminates, it will also call the destructor for van 1, and then it will try to delete the dangling pointer, and you can't because that address is not yours anymore. So that's why now it's crashing. So again, don't do this. Let's put it here as a comment. Don't do it. Okay, now this will still crash because here we have the copy constructor. So let's fix this one. So in order to define the copy constructor, this is another constructor. The difference is that the copy constructor will always ask for another object. And remember that any function which receives an object by value will call the copy constructor. Yeah, but this is the copy constructor, so you'll have infinite recursion. So in order to avoid the copy constructor, when you have functions like this, you need to give me the object without using its value. So what's the other way? Either using the reference or either using the pointer. You see, again, the advantages of pointers. If we always pass pointers to objects, you don't need the copy constructor. So the conclusion will be always use pointers or references to the objects because you don't need the copy constructor. But if you pass the object itself, its value, you need the copy constructor. So again, pointers and references have another advantage versus not using them. So in order to not make the copy constructor call itself, we will use the reference approach. Now, the danger when you receive a reference or a pointer to an object is that you can actually change it. Remember, this is the power of receiving something by its reference. You can change that thing inside the function. Here, you can change the driver name. You can say driver equals none. So generally, we don't want to do this in the copy constructor because this is the object which is giving us the values. Here in main, this will be van 1. So here the logic here is to copy the values from van 1 into copy, not to change van 1. So this will be a logic mistake. So in order to prevent this for happening, again, we will use const. Remember, we also use this for arrays in order to prevent us for doing this mistake, because now you get the compiler error. It's saying, hey, I don't think you want to do this, okay? You don't want to change van. So this is one way of defining the copy constructor. So now what do? We initialize the data of the new object by taking values from van. Now, remember, this is again a constructor. So it's a copy constructor, but it's still a constructor. So don't be surprised you have this error again. You see, provides no initializer for const member volume. So again, here, you need to initialize the constant as before. So volume, and now from where do you take the value? I take it from van. So van volume, because I want to clone the van. Okay, I want to create a vehicle with the same characteristics. Okay, you can still use this for the driver if you like. So again, it's optional here. Again, I'm taking the value from the driver. from the van driver, or you can write it here, but don't keep both. It's redundant. You do the same stuff twice. Okay, van driver. Okay, so let's comment this one. And now this is what makes our version better than the default one. If you do this, locations equals van locations, this is exactly the issue with the default copy constructor. This is the shallow copy, which will lead to a dangling pointer, which will lead to our application crashing. Okay, so don't do this. Okay, here we need to create a new array. We covered that. So how do we do this? This locations equals new string. I will finish in 2 minutes. New string of van number of deliveries. Okay. Let's create also the number of boxes. New int of the same value, van number of deliveries. And now we copy them. I will copy both arrays in the same time. For int I at 0, I less than van number of deliveries, I plus plus. Here I will have this locations at index I equals with van dot locations at index I. One it's a pointer, one it's an object. That's why here I use dot, here I'm using arrow. This is a pointer. Number of boxes at index I equals van number of boxes at index I. So here I'm copying both arrays. And now don't forget to initialize number of deliveries, then number of deliveries. And don't forget about the static, because here we are creating a new van. So delivery van, number of delivery vans plus equals 1. Okay, we are creating a new van with values from the previous one. And this is the copy constructor. So if I will rebuild this and run it, I have the exe opened. When you see that error, at least it will not crash. Okay, but without the copy constructor, it will crash. And you see how many destructors we have here, because we are creating copies and those copies are destroyed and so on. So this will be an interesting exercise to try to figure it out, why we have here 7 destructors. Okay, and where are those objects created and when they are destroyed.